Combine harvesters are the miracle machines of mechanical engineering. You may observe a magical technology in this corn combine harvester. The combine allows only the corn ears inside the machine and discards the remaining plant. Open the cover of this corn header, you can see this genius mechanism. As the combine moves forward, these header cones help the plants to reach in the region of the mechanism. Now comes the magic. You can see a pair of spinning square bars. Can you tell what they will do to the plant? Initially, the gap between the squares is wide. As they rotate, the gap becomes small and the plant is pushed down. After a small break, one more pushing down. However, after a few cycles, the plant is stuck. The corn ear is not able to pass through the narrow gap of deck plates. However, the square bars are still trying to push the plant down. This means, eventually, the corn ears should get removed from the plant stalk. Once the corn ears are removed, these guiding chains come into action. They will make sure that the corn ears will reach the auger. These cutting blades below the mechanism will make sure that the whole operation is much easier. The augers make sure that the corn ears collected from a large area get concentrated toward the center of the machine. The beauty of a combine harvester is that you encounter a different crop, the same machine can still do the harvesting, but with a different header. In the case of wheat, the combine cuts the whole crop and sends it forward for threshing. Is the machine cutting the crops in a human style? No, the machine has a smarter method.
The trick is support and the speed. Wow, what a perfect cut.
These high-speed oscillating blades perform the same cutting action. Look at the hidden supporters of the cutter head. Due to the high speed and support, the plant is unable to flex and undergoes a perfect cutting. What if the ground is irregular? Don't worry, modern combine cutter heads are flexible. After the cut, the reel pushes the crop into the auger. In fact, even before starting the cut, the reel gently pushes the wheat crop toward the machine, holding it steady for the cutting action. As we have seen earlier, the augers collect the crops toward the center of the combine. From here, the crops reach a feeding conveyor, a chain with cast iron slats. The feeding conveyor makes sure that the crops reach inside the machine to meet the most important part of the combine harvester, the thresher. At one end, the thresher is fitted with a spiral vane. This allows for the smooth entry of the straw. The threshing cylinder is fitted eccentric to this concave grid plate. This means when the cylinder rotates, the straw gets threshed between the cylinder and the rasp bars. But wait, what if the straw gets trapped between these rasp bars and escapes moving spirally? Engineers are tricky. They provided vanes in the direction opposite to the spiral of the rasp bars. Now, the escape motion we discussed is not possible. The crop has to get crushed under the threshing cylinder. This is an axial type threshing unit. From the main threshing region, the majority of the grain gets separated and falls down. Please have a look at this interesting motion of the concave. This positional adjustment is crucial for separating the crops with minimum damage and maximum efficiency. To understand why, let's first learn the physics behind how the grain is detached from the stalk and husk. The physics of the thresher is exciting. The first mechanism is impact threshing. This animation tells it all. Can we go for extreme speed on the thresher to achieve maximum threshing? No, this would lead to crop damage. There is a critical velocity for the thresher. Beyond that, we cannot increase the speed. The next mechanism is rubbing threshing. The way rasp bars rub the grain ear against the concave grates is shown clearly here. Sometimes 2 or more grains can undergo the rubbing action. The only goal here is to knock the kernels out of the seed head. Look closely at a new mechanism. This is known as grinding threshing. Here, you can observe huge crop damage. What is happening here? Here, the thresher is applying normal force to the grains. The grains undergo a compressive force, and the chance of them getting damaged is high. Engineers always try to avoid such situations. A tighter clearance creates more aggressive rubbing and impact. It's necessary for tough-to-thresh crops to knock all the kernels out of the head. The risk is that a gap that's too tight will lead to grinding threshing and damage the kernels. A wider gap is gentler on the crop. It's used for delicate, easy-to-thresh crops like dry beans or some soybeans, or for corn where you just need to shell the kernels off the cob. You can see what's the risk of a gap that's too wide. Advanced combines use automation systems, like John Deere's Combine Advisor or Claas's Chemos, to decide the optimum clearance. It's time to introduce a modern combine's eyes, the internal cameras and sensors. They monitor the grain quality in real time. If the cameras see too many broken kernels, the automation system will automatically widen the concave clearance and maybe slow the rotor to be gentler. If the loss sensors detect too much grain going out the back, the system will automatically tighten the concave clearance to thresh more aggressively. Along with this flowing straw, you can notice some grains which are separated but trapped inside the straw. This region of the thresher is called the separation region, the second stage of grain removal. Here, due to the centrifugal force effect, the grains get separated from the straw and fall down. The grains coming out of the thresher and separator region are obviously not pure. They are full of short material, and sometimes the grains have unremoved husks. Let's see the cleaning process. The grain and short material falling through the concave are collected by augers and pushed forward. Eventually, they reach a series of straw walkers. These are long, oscillating trays with holes in them. The straw walkers move with a back and forth, up and down motion. Look at the beautiful mechanism driving the straw walker. The material from the separation region also reaches the straw walkers. The oscillating motion makes it difficult for the short material to pass through the holes, especially when air flows over it. However, the grains can easily pass through. The high-speed air is supplied by this blower. This airflow has one more crucial job. Consider these two grains falling down. One is perfectly separated from the chaff, the other still has some chaff on it. When the air blows, which one will move farther away? Obviously, the second one. Let's take the camera to the other side. You will be able to see an interesting grain transfer mechanism. This way, the grains that are 100% free of chaff are collected in one collection pan, and the grains with some chaff content get collected in another. What to do with these not-so-pure grains? Simple trick, re-thresh them. The grains that are 100% free of chaff are pushed by this auger at the bottom and collected in one area. From here, the grains finally reach the storage tank. The grain tank is fitted on the top of the combine. The grain tank is equipped with sensors monitoring the grain level. When the tank is full or near full, an alert is sent to the operator's cab so they know when it's time to unload. Please have a look at an automatic way the combine unloads the grain when the tank is full. The heart of most modern combine harvesters is an inline 6-cylinder diesel engine. They produce between 300 and 700 horsepower. Most of these engines are turbocharged. Look at the functions the engine is able to perform. It drives the wheels, spins the thresher, runs the blower, runs the straw chopper, runs the auger, and even powers the hydraulics. How does the engine power get transferred to these parts? Combines use a complex belt and gear system to transmit power. To make the explanation easier, we built a simplified but working system. We use the service of JLCMC for ordering different mechanical components. This website is a paradise for mechanical engineers. You can order everything from transmission components to sensors and switches on this website. Generally, you won't be able to purchase parts with industrial quality in small quantities. However, at JLCMC, you can do so. The parts are affordable too. 1 week after ordering, I received this box, a box full of gears, belts, and bearings. Look at the simplified power transmission of a combine we have built. The power from the engine is first transferred to the transmission. Here, the torque gets multiplied. After the torque multiplication, the power reaches the drive wheels of the combine. This simple drive belt runs a blower. Now let's focus on the remaining power transmission. The thresher is run by another belt gear system. The way the auger gets power is tricky. Initially a belt transmission, after that a worm gear arrangement. The only thing remaining to explain is the power transmission to the chaff fan at the outlet. Here, a combination of belt transmission and bevel gear arrangement is used to transfer power to the chaff fan. We will soon see the use of a chaff fan. From these flowing arrows, you can easily understand how the power from the engine is getting divided and reaching different components. The beauty of a combine harvester is that you can encounter a different crop, but use the same machine with a different header. We've already seen in detail how the corn is harvested. With the help of this animation, enjoy the remaining processes in corn harvesting. Of course, in the thresher, the clearance has to be different for corn separation. All these parameters are adjusted automatically when the farmer selects the corn option. With this corn header, even sunflowers can be harvested. Modern combine's versatility is surprising. With the same header, you can easily drive from a wheat field to a barley field, oats field, or flax field and still harvest them with great efficiency. If the wheat header is flexible, you can even harvest soybeans. Of course, the machine has to change the combine's internal settings like thresher clearance, rotor speed, fan speed, and sieve opening to achieve this. The fun part? For a modern combiner, this is an automatic operation. You might have seen combines with these kinds of special tires, triangular crawler tracks. The primary objective of triangular crawler tracks is to reduce soil compaction. The large surface area of the tracks distributes the immense weight of the combine harvester far more evenly than tires. This significantly reduces ground pressure, preventing deep soil compaction. Moreover, in wet, muddy, or hilly conditions, crawler tracks provide superior grip and stability. The larger footprint of the tracks prevents the heavy machine from sinking into soft or wet soil. It is possible to modify an existing wheeled combine harvester to a triangular crawler track system. This process is commonly referred to as retrofitting or conversion. Now, let's discuss more about the most crucial part of a combine, the thresher. Interestingly, even the vane angle of the thresher is adjustable. The primary need for this adjustment is to control the speed of the crop as it spirals through the rotor. A steeper angle is more aggressive and moves the material rearward faster. A steeper angle can be used if the crop is very dry and easy to thresh. A shallower angle holds the material in the rotor longer or increases the residence time. If the crop is damp or hard to thresh, you need more time to get the grain out. The most advanced automation systems, like New Holland's IntelliSense or Case IH's Harvest Command, have fully automated vane angle control. The system uses data from the grain loss sensors and the grain quality cameras to decide the best vane position. If the system sees grain loss out of the rotor, it will automatically slow the vanes. If it sees broken grain or an overloaded sieve, it may speed them up. Here is an interesting challenge for you. This farmer wants to harvest this field. Will he run the combine in a normal back and forth pattern? This method may not be practical. Combines have a large turning radius. To turn 180 degrees tightly, the driver often has to stop, reverse, turn, and go forward again. Please have a look at what a clever farmer does here. At first, his land pattern looks counterintuitive. Please wait and watch the final result. Of course, to run the combine like this, the operator has to be skillful. Now, an interesting question arises. What to do with all these crop residues? Generally, they are dumped back into the field. There are some chopper wheels at the exit of the combine. Before dumping into the field, we have to chop the straw into small pieces. This tailboard can distribute the residue up to 9 meters. If there is wind affecting the residue distribution, the auto-swap system automatically changes the direction. You might have seen a yield moisture sensor in a combine. What's the purpose of this? During day-long harvesting, as evening approaches, dew can cause the grain moisture to rise quickly. If it goes above a certain level, the operator will stop harvesting because grain harvested with high moisture cannot be stored as it will quickly mold and spoil. The operator has to wait for the next day to resume harvesting. More specifically, he waits until the sensor shows the moisture has dropped to an acceptable level. The moisture sensor allows the farmer to manage this process perfectly. Harvesting in a hilly region is an interesting challenge. What you can observe here is that the angle of the header and the angle of the main car body are different. Yes, the header of a combine can tilt. This angle adjustment makes sure that even on hilly terrain, the combine will work perfectly. A modern combine has more than 20 critical parameters to adjust to achieve a high harvesting efficiency. Remember, more than 99% of grains present in the field will eventually reach the grain tank. Modern combines achieve this with the help of predictive harvesting technology. This technology uses sensor fusion to scan the crop in front of the header. Based on the input from the sensors, the machine's critical parameters are adjusted before the crop enters the feeder house. Remember, this technology is exactly opposite to the traditional reactive method where the machine adjusts the parameters only after the crop has entered the machine.
This website is a paradise for mechanical engineers, JLC MC. You'll get any mechanical components for industrial or hobby purpose from here. So before you leave, please don't forget to check out jlcmc.com. Take care, bye bye.